Hi, Dan. You are there?
Yeah, I'm here.
Okay, let's give them a few minutes now that they're just coming from another session.
Okay.
You can start at 3:35.
Okay.
Hi, Dan.
Hey.
I think you're good to go.
Okay. Uh, Hi everyone. So I'd had a session with some of you last time, and for those of you who are not around, I think I'll start by introducing myself. So I'll just share a screen here of a PowerPoint presentation that I prepared. It's sharing. It's taking a bit of time, but it's loading. Are you able to see?
Yes, Dan, we can see your screen.
Okay, so this is a PowerPoint presentation that I'll share with you. So let me start by introducing myself. So my name is Dante Seret. That's my Twitter handle. That's my email, and that's my blog, stroke website. That's where I usually blog some of my projects and some of the methodologies that I use for my projects. So who I am, I'm a web software and data developer, an associate data visualizer for predictive analytics, consulting developer for Maloney, freelance developer at Visual Data, as well as a data scientist at visualdata.co.ke. So here with the screen are some of my projects. I don't know whether you're able to maybe click on the screen or I share on the chat, but these are some of the projects that I did. Deadly Force was for Nation Media. County Performance Ranking was for Infotrack. Deadly Sports on Nairobi Roads was for Nation Media. 30 Years of HIV for Internews. Asylum Seekers for Nation Media. Cancer Causing Agents for Business Daily. So for this lesson, we're going to look at the spectrum of colors in data visualization, and then aspects of interactive data visualization. So the last lesson is where we are going to do the practicals, where we're going to upload the actual data sets to some of the tools that we have, and then we're going to do the practicals. So for this lesson, mostly I wanted us to concentrate on ensuring that we've grasped the concept of using colors in data visualization. So, so let's ask ourselves, what are the things to consider uh, when to decide whether or not you're going to use colors in visualizing data. So number one is that you consider if there's a better alternative to gradient colors when encoding most of our important values. So here we say that gradient colors can be great to show a pattern, for example, on a choropleth map, but it's hard to decipher the actual values from them and to see differences between the values. Are you able to click on the link? So I'll share another link. Let me try to see if I can open here. Okay, I can see someone is requesting I put it on a slideshow, as well as to paste the links on chat, which I'm going to do that. So I'm going to share links to some of my projects on their side chat. So there on the side chart are links to some of my projects. Maybe you can scroll through them when you have free time. So someone requested to do a slideshow. So we are done with the intro, who I am, projects. Then we are on the spectrum of colors when choosing data visualization. So if, for example, so we say the gradient colors can be great to show a pattern. For example, on a choropleth map, but it's hard to decipher the actual values from them and to see differences between the values. So basically, a choropleth map, which we are going to look at later on at a later lesson, it's actually also called a gradient map. So if I can click on this choropleth map, for example, can you all see the data, the
Yeah,
presentation?
you haven't shared your screen.
Oh, okay, sorry about that. Are you able to see now? Anyone?
Yes.
Okay. So, and the links on the side?
Yes, those ones came through on the chat.
Okay. So someone requested to do a slideshow. So I was talking about the choropleth map. It's also called a gradient map, which you see on mostly on news reporting sites. If I can just click on this one, then you can see an example of a choropleth map. So I'm sharing the link to the map. So there you have the link to the map. So gradient colors can be great to show a pattern. For example, on the choropleth map that I've just shared, but it's hard to decipher the actual values from them and to see the differences between the values. So consider showing your most important values. For example, bars, position, like in a dot plot or even areas, and to use colors to only show categories. Readers will be able to decipher your values faster that way. So I'd like to ask, since we had gone through some of the chart types that we have, is it essential that I share a demo for the guys that are not around, or we will catch up? Eric?
Just very, very brief overview, and then we continue. Don't have to go into great detail.
Okay. So I'll just share a link where you'll see the various kinds of maps that you can have on HighCharts. Maybe you can explore at your own time. So if you go to highcharts.com, the link that I've just shared, the last one, you'll see all the various types of charts, which are not going to go through again since we had already gone through them. So at your own free time, just look at the various types of charts there. So as an example, so whatever is not ideal when you're using colors here, on the left side of the screen, you can see the poor use of colors and the better option. So you see that in the first example we have, this is called, essentially this you'd call a scatter plot. But if you look at the color used here, for example, on the left side, we have people in group A with a color coding, with the darker one being rich and the lighter one being poor. But on the left side, you see that you're actually not able to decipher what it tries to mean in terms of the difference in terms of the, like, for example, the quantity. But on the right side, you see on the beta map, people in group A and B. So you can clearly see people in group A have a distinct color, which is a darker shade of blue, and people in color B have the light green. So you can see on the left side, this is not ideal, and then on the right side, that is the ideal use of colors. So another thing to consider is if you need more than 7 colors in a chart, consider using another chart type or to group categories together. At a later lesson, we are going to see that when you are using categories, you use what you call a divergent gradient. So here, colors make it easy to let readers distinguish between categories in our data, but try to avoid using more than 7 of them. So try to stick to less than 7 colors, whereby the eye can distinguish quickly. The more colors in a chart represent your data, the harder it becomes to read it quickly. Your readers will need to often consult the color key to understand what is shown in your chart. So consider using another type of a chart in this case. So if it is more than 7 colors. So here again, as an example on the screen, you can see what is ideal and what is better. So in the first one, you can see that it's very confusing. From A, B, C, D, all that until L. There are so many colors that you are not able to quickly distinguish the difference unless now you go consulting the key. What you see here, this is called the key or the legend. It's called a legend in Google Charts. Some of tools call it a key. I think probably you all know that. So it's better to use this type of a chart whereby we use a positive gradient. I mean a positive. You split it into two, for example, whereby you're showing a positive and negative. So this green aspect here, this could be 0. So on the left, we have negative, and on the right, we have positive. So if you're using more than 7 colors, it's better to use another type of a chart. Then we look at how to make better color choices. So you consider using the same color for the same variables. If you just use one color for all your charts, using the same color is the best option to make your article not overly colorful. For example, it's okay to show the unemployment rate in blue in the first chart, and a few paragraphs later, a GDP chart with the same color. One good example here is when you're using what you call a dashboard, which we saw in the first lesson, but still we're going to refer to it later when we're doing the actual visualization. So, however, if you use more than one color for your first chart, the colors in this chart will be taken in quotes, meaning that the color has, the eye has already associated the color with a certain, say, KPI or a certain variable. So if it's red, it has associated with danger, or if it's danger and you've chosen red for male, it has already associated it with male. So to not confuse readers and increase comparability, consider only using these colors again if you're showing data about the same category, country, etc. So we have an example there, but I'm not going to click. I'll just show it in an illustration. So on the left side again, we have the ideal. We have the not ideal, and on the right side we have the better option. So on this side, you can see, for example, UK is red and China is dark blue. And then on the same page, we have a pie chart here, but then you've already associated dark blue with China. Yet down here, China, you've changed it to red already. So this becomes confusing to the eye. So instead, you leave red to UK and then China blue. Then when you go to another chart again, you see here you picked China as a dark blue. So you keep it as a dark blue for China. And then Germany, you give it another color. This is another variable. So you give it another color. So another point is that you make sure to explain to readers what your colors encode, what your colors mean. So every visual that represents a value or a variable should be explained. What does the height of your bar mean? For example, what does the size of your circles on a symbol map represent? The same is true for colors. There are many ways to create a color key. So for example, down here we have three examples. These are examples of creating a color key. This first one is called a gradient. This is a linear gradient. The second one, it's a key that has been split using we call these like this 0 to 25 to 50, 75, 100. We call it buckets. So the first one is using a linear gradient. The second one is using buckets. The third one here, as you can see, China is marked in red. So you'll associate China. If it's a line graph and there's a line that has red, you'll know automatically it's China, and dark blue is for Germany. So another point, you consider the color gray as the most important color in data visualization. This is actually the norm in data visualization. So using gray for less important elements in your chart makes your highlight colors, which should be reserved for your most practical data points, stick out even more. Gray is also helpful for general context data, less important annotations to show what's unselected by the user or to calm down the overall visual impression of your chart. So this is another example. I'm going to share the link briefly so that you can see what I mean. So if you go to that example that I've just shared, when you click on, for example, Chrome or internet browser or Firefox or Edge or Safari, when you click on any of those, it is actually highlighted in gray to mean that the user has deselected. And the others that are remaining are your point of focus. I can't seem to figure out a way of sharing the browser that I have currently, but if you can click on that link, probably you'll be able to see. So going back to our presentation, so that was the use of color gray. Since gray can be a bit cold, consider using it with a hint of color. Try a warm gray. Gray that is a gray plus yellow plus orange plus red. That's a warm gray. Again, later on in the coming lessons, we shall see what the use of a concept called color wheel and color schemes, and how you can achieve, for example, that warm gray, the way you can mix gray, yellow, orange, and red to get a hue of a warm gray, or use another very light color as an alternative. So, for example, super yellow, as in this illustration here. So you can see what is not ideal and what is better. So again, on the left side, you can see that there are so many colors, yet you only need to focus on, say, one variable. So say, for example, you can see that when you're telling a story, for example, out of this line chart, your focus would be on the blue. So while it makes sense to use colors for all the other charts, if they're not really your main point of focus, you'd rather just use gray for all the other colors and use the dark blue to highlight whatever you're trying to communicate. The other point, make sure your contrasts are high enough. Caring about contrast means caring if your readers will be able to read your chart on their screen, even in low light, and even if you use light colors like gray. This is especially important for text. The smaller the text, the higher its contrast to the background. Needs to be for it to be readable. The contrast ratio between background and foreground should be at least 2.5 for big text and at least 4 for small text. In addition to having a high contrast ratio, avoid complementary use. That is, for example, red and green, orange and blue, and bright colors for backgrounds. So usually in most visualizations, you see that the background is usually a dull color, probably maybe white or shades of white or just a color or just colors that are neutral colors mostly. Then you leave the high contrast colors to the actual visualization. So the other point is consider where your colors appear in relation to each other. The smaller the areas on your chart and the bigger the distance between them, the harder it is to compare. Consider giving small points or lines a high contrast in their hue or brightness to make them easily distinguishable. However, big areas can handle toned down colors with little contrast, especially if there's no other background between these areas. So this is an example of what I'm trying to communicate. So again, on the left side, what is not ideal, and on the right side, what is ideal. So here on the left, this is a scatter plot, and you can also see that there are different hues. For example, this is lighter, this is darker, but to the eye, it doesn't make much sense since all the bubbles are the same. So, but on the right here, you can see the use of a gradient. It clearly shows because those are big patches. You can actually see the difference in the gradient. So that's better use on the right. The other point, you use intuitive colors. Intuitive means colors that people, for example, associate with, say, for example, certain events or certain parties. So here, when choosing a color palette, consider their meaning in the culture of your target audience. If possible, use colors that readers will associate with your data anyway. So for example, party colors in the US, we all know that Republican is red, Democrat is blue. And then for natural colors, we use green for forest. And even for in the case of guys of Carilo, agriculture, I'd say it's green. Then for lakes, it's usually blue. Or for example, land colors. So red is it's equal to attention or stop or bad. And then for green, it's good to go. As for example, like in traffic lights. When it comes to color encoding gender data, consider avoiding the stereotypical pink-blue combination. So pink-blue, most of the times in most illustrations, pink is associated with females and blue is associated with males. To not confuse your readers entirely, try a cold color for men, like for example, blue or purple, and a warmer color for women, for example, yellow, orange, or warm green. I remember when I was doing a visual for Nation Media on alcohol use, I used blue for men and light yellow for women, just to avoid a stereotype. But it doesn't mean that you can't still use pink and blue, but try to avoid as much as possible. So here is an example. So we have what is not ideal. You can see here red here is being used to indicate good, and then light green bad, forest is blue, female is blue, male is red. Then on the right, we have what is good. Good is, we have the blue, bad is red. We have forest there, a shade of green, blue, a shade of red. Male, the yellow I was talking about. Female, the yellow I was talking about, and male, the dark blue. Another point, use light colors for low values and dark colors for high values. When using color gradients, make sure that the bright colors represent low values while the dark colors represent high values. This will be most intuitive for readers. Makes a lot of sense. As you can see here on the left, we have a map. This is the choropleth map that I was talking about. For example, I can say this is an example of density of population. So here on the left, you can see what is not ideal is to use a dark color for low and lighter color for high. While on the right, we have what is ideal, where you are using a lighter color for low and a darker color for high. If you could go to the link that I gave you on the choropleth map on the population of United States, which was done using a leaflet, can illustrate that. And also the one that I did on county performance ranking in the link that I gave you also illustrates this very clearly. So the other point, don't use a gradient color palette for categories and the other way around. It might be tempting to use shades of one hue, e.g. blue, even for categories to make your chart look less colorful. However, since many readers will associate dark colors with more or high and bright colors with less or low, such a color palette will imply a ranking of your categories. And yet, for example, when you are displaying per category, it's not per rank. When you're doing ranking, you use gradients. Categories use different colors. So use different hues, for example, green, yellow, pink, etc. for your categories to avoid that and to be able to talk about these colors. So again, an illustration here. On the left, we have what is not ideal, and on the right, we have what is not ideal. This seems to be self-explanatory. This is data visualization. So whatever you perceive with your eye, although at a later stage again, you're going to see that there are people who are colorblind. You also need to take care of them when you're doing your visualizations. If you have any question, you can always ask. So use lightness to build gradients, not just you. If you're unsure about color gradients, use Color Brewer. Color Brewer is, let me share the link, but don't worry about it so much. We'll have a look at it at a later stage, but it's a tool that helps you to choose colors. We're going to again at a later stage look at tools that you can use to help you choose colors, especially seeing as some of us are coders and not designers. So these are tools that will help you to choose colors. So I'm going to share the link to Color Brewer. It's on the chat there. So that's the link to Color Brewer. Sorry about that. I'm looking for the current slide. There. So if you're unsure about color gradients, use Color Brewer or Kato Gradients. That's another tool. We have about 5 tools that can help you choose colors. So for example, if you go to Color Brewer, you'll see that there are different palettes that we have. So we will again look at that at a later stage. A color scheme is a collection of multiple colors chosen to be used together on a graphical work, such as a map. I think we all know what a map is. Diverging color schemes are best used to highlight both high and low extreme values or values that differ slightly from the norm. Again, on Color Brewer, you will see that we have palettes. We have diverging, sequential, and qualitative. We'll look at them in detail later on. So I'll just mention them here. So that was diverging. We also have sequential. Sequential color schemes are logically arranged from high to low, and is often used in creating a map with sequential lightness steps. Qualitative show differences between categories with different hues. Lightness should be similar, although small lightness differences are necessary for the colors to be distinguished from one another and allow areas to be identified more easily. So we have an example here of the use of gradients. We have a hue-based gradient and lightness-based gradient. Lightness sometimes is also called saturation, as we'll again later on we'll look at it. So that is hue-based. We have hue and we have a saturation. So you can either use hue or saturation or lightness to achieve the gradient. The other point is consider using two hues for a gradient, not just one. Readers will be able to distinguish the colors on the gradient better if they are encoded through lightness and two or three carefully selected hues. This is to make your map or chart even more decipherable. So use Color Brewer to help you, for example, achieve those hues. So here we have one that is not so bad and one that is even better. So we have one hue on the left and two hues on the right. You can see that the one with two hues is even better than the one with one hue. It's more decipherable to the eye. The other point is consider using diverging color gradients. If you want to emphasize how a variable diverts from a baseline, I'm sure by now you know what a variable is from the previous classes, especially with the practicals with Python. If you want to emphasize how a variable diverts from a baseline, say the national average, for example, you may want to consider using a diverging palette. It's important to use clearly distinguishable hues for both sides of the gradient. The center color should ideally be a light gray, not white. Here is an example. So this bit here is the center, and you see the two centers here, here and here. So you can see we have we can say this side you can call it the negative gradient and this is the positive gradient. So here, for example, you can see that these are two different colors just to make it more distinguishable. So we have the not ideal on the left and the better on the side. So not ideal doesn't mean that you can't actually use it. You can still use it, but it's not so ideal. So the point I was talking about is that you have to consider colorblind people. Using different lightness in your gradients and color palettes has the big advantage that readers with a color vision deficiency will still be able to distinguish your colors. There are many different types of color blindness. Sorry about that. So there are many different types of color blindness. Use an online tool or data wrappers automatic colorblind check. If you've opened Color Brewer, you will see that there's an element that is used to help colorblind people, so that you can choose the different types. You can choose a color that will help colorblind people distinguish whatever you're trying to visualize. So that was my point on colorblind people. So data wrapper, this is an example of, let me see if I can rotate. So this is the color blind that I was talking about. We have different types of color blind abnormalities. So we have this protanopia, deuteranopia, and anormal vision. So you can see that there are different types of colorblind people. So if you're not sure, it's better that you use an online tool like Data Wrapper to help you distinguish those colors. I think it's good that sorry, not Data Wrapper, I mean Color Brewer. It's good that you explore Color Brewer because at a later on stage again, we'll use it to practically get gradients for maps. So so you consider colorblind people when you're making your visualization. So here we go to questions that you need to ask when deciding which types of charts to use. So I'm assuming that by now we all know there are the various types of charts that we have. And if not, you can explore through the link that I gave. Here we have, we call it a DFD, a data flow diagram of decisions that you use to make. Let me just share the link. It will help you to make the decisions when you want to choose which type of chart you want to use. So on chat, I've shared a link to the DFD, to the data flow diagram that I was talking about. Are we able to see the diagram on screen? Anyone?
Yes.
Okay. So I've shared the link there. So this data flow diagram will help you choose which type of a chart you'd want to use when you're making a visualization. So the first question you'll have to ask yourself is, do you have more than one variable? So we have a yes or a no. If it is a no, for example, you now move to the next point here. Or if it's a yes, you go the other way. So if it's a no, so is it ordered? So it's either a yes or a no. So again, if it's a no, you go to the last link here. So for example, a histogram here has the features that it's not ordered and you don't have more than one variable. I hope you all understand what this is actually, it's also called a decision tree. It helps you make decisions. So if it's a yes on this other side, you ask yourself, are they similar? Yes, no, are they ordered? And eventually down here, you'll choose the type of a chart that you want to use for your visualization. So here we have the various types of maps. We have a heat map, tree map, stacked map, pie chart, stacked line. A sun key diagram is like the one that I've shared in none of the links for asylum seekers. I think the rest here we had looked at them, line chart, area, scatter plot. Just have a look at them from the link that I gave you on the demo for high charts. So that's the link to the decision chart. So maybe we'll try to have a look at one of them one by one on how to choose the right chart or graph for your data. So question number one you have to ask yourself is, do you want to compare values? So at this point, I'd urge all of us to try and concentrate on this, because at the end of the lesson, we'll have a small quiz to see if you have a bit of an idea on the right kind of charts that you want to use for your data. So point number one is, do you want to compare values? Charts are perfect for comparing one or many value sets, and they can easily show the low and high values in the data set. To create a comparison chart, use these types of graphs. So I'm going to list the types of charts that you might want to use when you want to create a comparison. So we have number one is a column chart. You can refer to the demo link that I gave you, look for column charts. So we have a column chart, a tree map, a bar chart, a pie chart, a line chart, a scatter plot, and a bullet. So those charts are useful when you want to create comparisons. So when you want to compare values, you use these types of charts. So number two, do you want to show the composition of something? Use this type of a chart to show how individual parts make up the whole of something. For example, the device type used for mobile visitors to your website, or total sales broken down by sales rep. So to show comparison or to show composition, use these charts. We have a pie, a stacked, a tree map, a stacked column, an area, and a waterfall. So those charts are suitable when you want to show the composition. Like for example, a pie chart usually shows the percentage of something as a whole. Point number three, do you want to understand the distribution of your data? Distribution charts help you to understand outliers, the normal tendency, and the range of information in your values. So we use the following charts when you want to understand the distribution of your data. So we have a scatter plot, a MECO. MECO, this is also called a tree map. It's also called a MECO. We have a line chart, a column chart, and a bar chart. So use those charts when you want to understand the distribution of your data. Point number four, are you interested in analyzing trends in your data set? If you want to know more information about how a data set performed during a specific period of time, there are specific chart types that do extremely well. So you could use a line chart, a dual axis line. A dual axis line is a line chart that has an axis on the left and on the right side. And then you can also use a column chart. So use those kinds of charts when you're interested in analyzing trends in your data set. Point number five, do you want to better understand the relationship between value sets? Relationship charts are suited to showing how one variable relates to one or numerous different variables. You could also use this to show how something positively affects, has no effect, or negatively affects another variable. When trying to establish the relationship between things, use these charts, relationships. So you use a scatter plot, a bubble chart, or a line chart. So use those charts when you want to better understand the relationship between value datasets. Now that we know what kind of charts to use for various visualizations, we're going to look at design best practices for charts. So number one, we look at column charts, best practices for designing column charts. Use consistent colors throughout the chart, selecting accent colors to highlight meaningful data points or changes over time. Use horizontal labels to improve readability. Start the y-axis at 0 to appropriately reflect the values in your graph. So in the previous lesson, we looked at a graph that, I don't know whether it was this class, we looked at a chart that was starting at 35, at a bar chart that was starting at 35 at the y-axis, and the chart next to it was 37. The difference was very small, but starting at 0, you could see that the difference was actually very big. So start the y-axis at 0. So this is an example of a column chart with the y-axis starting at 0. Number 2, we have a bar graph. Use consistent colors throughout the chart, selecting accent colors to highlight meaningful data points or changes over time. Use horizontal labels to improve readability. Again, start the y-axis at 0 to reflect values. That is an example of a bar graph. So the other one is vertical, this one is horizontal. That's the difference between a column and a bar. So number 3, best practices when using when illustrating with a line graph. Use solid lines only. Don't plot more than 4 lines to avoid visual distractions. And if, for example, you have more than 4 lines, like we said, only use colors for the variables that you want to highlight. Use the right height so that the lines take up roughly 2/3 of the y-axis height. So that's an example of a line graph. Then we have the dual axis chart. A dual axis chart allows you to plot data using 2 y-axes and a shared x-axis. X-axis is the bottom, the vertical is the y. It's used with 3 data sets, one of which is based on a continuous set of data, and another which is better suited to being grouped by category. This should be used to visualize a correlation or the lack thereof between these 3 data sets. So best practices for a dual axis. Use the y-axis on the left side for the primary variable because brains are naturally inclined to look at the left first. So left primary variable. Use different graphing styles to illustrate the 2 data sets as illustrated below. Choose contrasting colors for the two data sets. So this is an example. It's sometimes called a combined chart. Like if you go to the link that I gave on the high charts, you'll see that it's called a combined chart. So it's the combination of this one is a combination. Actually, this is a combination of dual axis and a line chart. We have 2 axes. So on the left we have new customers. On the right we have sum of revenue. So as you can see, the scales don't have to be equal. This other one is the scale on the right is in terms of dollars, and this other one is just numbers. So that's an example of a dual axis. So we have an area chart. An area chart is basically a line chart, but the space between the x-axis and the line is filled with a color or pattern. It is useful for showing part-to-whole relations, such as showing individual sales reps' contribution to total shares for a year. It helps you to analyze both overall and individual trend information. So best practices when doing an area chart. So you use transparent colors so that information isn't obscured in the background. Don't display more than 4 categories to avoid clutter. Organize highly variable data at the top of the chart to make it easy to read. So this is an example of an area chart. So as you can see, it's actually a line chart, but with the areas filled. So this is an area chart. Then we have a stacked bar chart. This should be used to compare many different items and show the composition of each item being compared. It is best used to illustrate part-to-whole relationships. So best practices is use contrasting colors for greater clarity. Make chart scale large enough to view group sizes in relation to one another. So this is an example of a stacked bar chart. It's actually a bar chart, but now with stacked bar chart. Next, we have a pie chart. So best practices are don't illustrate too many categories to ensure differentiation between slices. Ensure that the slice values add up to 100. Again, I said this is best used to show composition. And then order slices according to their size. We find that most of the time this is automatically done by the library that you are using. It usually orders slices. It usually orders slices according to their size. So this is an example of a pie chart. You can see that if you add the percentages here, they should add up to 100. So it shows composition. That's a pie chart. Next, we have a scatter plot chart. A scatter plot or a scattergram will show the relationship between two different variables, or it can reveal the distribution trends. It should be used when there are many different data points and you want to highlight similarities in the dataset. This is useful when looking for outliers or for understanding the distribution of data. A scatter plot. Include more variables such as different sizes to incorporate more data. Start y-axis at 0, again important to represent data accurately. If you use trend lines, only use a maximum of 2 to make your plot easy to understand. So this is an example of a scatter plot. Sometimes you can combine a scatter plot with a bubble chart. As in the example of we have a tool. We have a tool by this Swedish guy who recently passed on. I'll look for the presentation there. Probably I'll show it to you. It's a combination of an animated scatter and a bubble chart. So here we have a bubble chart. Best practices: scale bubbles according to area, not diameter. Make sure labels are clear and visible. Use circular shapes only. Very important. Only circular shapes. So this is a bubble chart. So next we have a heat map. A heat map shows the relationship between two items and provides rating information such as high to low or poor to excellent. The rating information is displayed using varying colors or saturation. So that's a heat map. Best practices: use a basic and clear map outline to avoid distracting from the data. Use a single color in varying shades to show changes in data, and then avoid using multiple patterns. So this is an example of a heat map. So before I proceed, I'd like to ask if perhaps if I'm rushing too fast or you're okay with the speed. Just a minute, I'm trying to get something here. I'm still here. So what we've looked at is the different types of charts, and then best practices, and when to use the various types of charts or graphs. So next, we're going to look at the use of interactive features in data visualization. So interactive data visualization refers to the use of software that enables direct actions to modify elements on a graphical plot. Interactive data visualization refers to the use of modern data analysis software that enables users to directly manipulate and explore graphical representations of data. Data visualization uses visual aids to help analysts efficiently and effectively understand the significance of data. So we have what you call as, it's either visualization is either static or interactive. Static, for example, is what we use on print newspapers, better known as infographics. And then interactive is what we use on web. So creating various interactive widgets, bar charts, and plots for data visualization should start with three basic attributes of a successful data viz design: available, accessible, and actionable. So those are the three important attributes of successful visualization that is interactive. So it is available, accessible, and actionable. Available: is there sufficient data source data available to meet your data visualization goals? So availability. And then accessible: can you present this data in an accessible manner so that it is intuitive and comprehensible? That's accessibility. And is it actionable? Do your data visualization interactions provide meaningful and actionable insights? So available, accessible, and actionable. The general framework for an interactive data viz, you'll find that mostly most visualizers call it data viz. So when you hear me saying data viz, it's data visualization. The general framework for an interactive data structure project, this data structure project typically follows these steps. So number one, this is the framework. Number one is you identify your goals, the desired goals. So number two, understand the challenges presented by data constraints. Number three, design a conceptual model in which data can be quickly iterated and reviewed. So it typically follows those three steps. Identify your goals, understand the challenges presented by data constraints, and then design a conceptual model in which data can be quickly iterated and reviewed. With a rough conceptual model in place, data modeling is leveraged to thoroughly document every piece of data and related metadata. Metadata is for example data that you cannot. For example, if you have a file, when you right click on that file, whatever you see there, for example, created by, modified by, is what you call metadata. This is followed by the design of a user interface and the development of your design's core technology, which can be accomplished with a variety of interactive data visualization tools. So next, it's time to test. It's time to use a test in order to refine compatibility, functionality, security, the user interface, and performance. Now you are ready to launch to your target audience. Methods for rapid updates should be built in so that your team can stay up to date with your interactive data viz. So we look at benefits of interactive data visualizations. An interactive data visualization allows users to engage with data in ways that are not possible with static graphs, such as big data interactive visualizations. Interactivity is the ideal solution for large amounts of data with complex data stories, providing the ability to identify, isolate, and visualize information for extended periods of time. So we look at some major benefits of interactive data visualizations. So keep in mind that this is not just data visualization, it is interactive, not static. So some benefits are that it helps you identify trends faster. The majority of human communication is visual, as the human brain processes graphics magnitudes faster than it does text. Direct manipulation of analyzed data via familiar metaphors and digestible imagery makes it easy to understand and act on valuable information. So it helps us to identify trends faster and then identify relationships more effectively. The ability to narrowly focus on specific metrics enables users to identify otherwise overlooked cause and effect relationships throughout definable time frames. This is especially useful in identifying how daily operations affect an organization's goals. So it helps us to identify relationships more effectively. It helps us also in useful data storytelling. Humans best understand a data story when its development over time is presented in a clear, linear fashion. A visual data story in which users can zoom in and out, highlight relevant information, filter, and change the parameters, promotes better understanding of the data by presenting multiple viewpoints of the data. So in an interactive visualization, for example, it gives the user the ability to interact with the data, for example, through filters, as said here. And so by filtering, as in the case of a dashboard, for example, it helps us to better understand the data by presenting multiple viewpoints of the data. So the other point is that it helps us to simplify complex data. A large data set with a complex data story may present itself visually as a chaotic, intertwined variable. Incorporating filtering and zooming controls can help untangle and make sense and make these messes of data more manageable and can help users glean better insights. I think the best example of simplification of complex data is a Google Map. Google Map enables zooming. So at a glance, when you zoom, for example, to a small point, you only see the macro, which is the the overall, and then as you zoom in, you get to see the finer details. So it's through interactive data visualization, it helps us to simplify complex data. So we are going to look at static versus interactive data visualization. A static data viz is one that does not incorporate any interaction capabilities and does not change with time. For example, an infographic focused on a specific data story from a single viewpoint. As there are no tools to adjust the final results of static visualizations, such as filtering and zooming tools, it is essential to give great consideration about what data is displayed. So let me share this link. It's an example of an interactive data visualization. So if you can just briefly, if you can open that link and just briefly have a look at it as I get something here. So I hope that we've all opened that link. So we'll just have a look at it, then we'll have a brief, maybe about a 5 minute discussion towards the end of the lesson about it. But the reason I wanted you to see it is because this is an interactive data visualization. It's by the Washington Post, and it's a combination of so many types of charts, including one including software that we are going to look at maybe later. But it's really very technical. It's called D3. Yeah? It's a low-level data visualization language. Like for example, the dots that you see that are moving from left to right and stuff. But it's basically a combination of so many things, and even including an animated scatter plot chart. So it's how coronavirus is spreading, the different types of visualizations. So this is what I mean by interactive data visualization. I'd like to we'll break at 5:30, but I'd like to just maybe introduce something here. We'll have a small quiz at the end of the session just to see that you've understood when to use what type of a chart, because that was actually the whole point of this lesson. So let me just introduce what you call the building blocks of data encoding. If you can see on your screen. So let me introduce the building blocks of data encoding. Then we'll have a look at it in detail in our next lesson. So encoding in data visualization basically means translating the data into a visual element on a chart or a map or whatever you are making. You need to do it right, because doing it right will mean that other people looking at your visualization can understand what you're trying to say or show. So encoding in programming, encoding means something different. Encoding means changing it into a different kinds of formats. For example, we have what you call JSON, we have what you call CSV, but in data visualization, it means translating the data into a visual element. So we want to look at ways of encoding data. So this is what we call the visual cues. So we can encode data, for example, by position. We can encode by length. We can encode by angle, by direction, by shapes, by area, by volume, or by color. I think we had briefly looked at encoding by color, which was color saturation or color hue. Color saturation or color hue. Yeah, we had a brief look at that. So we look at so encoding by position. So encoding by position, for example, is encoding by where in space the data is. What you're seeing on your screen, for example, is a scatter plot. So we can encode data by position. When you use position as a visual cue, you compare values based on where others are placed in a given space or coordinate system. For example, when you look at the scatter plot, you can judge a data point based on its X and Y coordinates and where it's relative to others. So this is what you have on your screen are different ways of encoding by position. So these are scatter plots. So as you can see, here we can have an upward trend. we can have a downward trend, we can have a clustering, and an outlier. So that is encoding by position. So one of the advantages of just using position is that it tends to take up less space than the other visual cues, because you can draw all the data with the X and Y plane, and you can represent each point with a dot. Unlike other visual cues that use size to compare values, all points in a position-based plot are the same size. In turn, you can spot trends, clusters, and outliers by plotting a lot of data at once. However, the advantage of using position alone can also be a disadvantage. If you look at a lot of points at once in a scatter plot, it can be a challenge to identify what each point represents. Even in an interactive plot, you still must use a mouse over or select a point to find out more information, and overlap can cause more problems. So that was so encoding by position. An example we looked at is a scatter plot. Again, you can encode by length. Encoding by length means encoding by how long the shapes are. As you can see on your screen, that's encoding by length. Length is most commonly used in context of bar charts. The longer a bar chart is, the greater the absolute value, and it can work in all directions, horizontal, vertical, or even at different angles on a circle. How do you judge length visually? You figure out the distance from one end of a shape to the other end. So to compare values based on length, you must see both ends of the lines or bars. Otherwise, you end up with a skewed view of maximums, minimums, and everything in between. As a simple example, as shown in the diagram below, a major news outlet displayed a bar graph on TV that compared the tax rates before and after a date. So here, I was talking about having the axis starting at 0. So here with the left, we have an axis starting at, for example, 34% here. So you can see this is 35% and this is 39%. But if you look at if you look at this, the difference here to the eye, the difference here seems so big. Reason being that the axis starts at 34%, but when you start at 0, the difference is clear to the eye that it's just quite small. So this is an axis starting at 0. So we have here an incorrect bar graph and the correct one on the right. So start your axis at 0. The difference between the two values looks like a huge increase. The length of the right bar is about 5 times the length as the other, because the value axis starts at 34%. The chart on the right shows the change when the axis starts at 0, which looks less dramatic. Of course, you can always look at the axis to verify what you see and what you always should. But that defeats the purpose of showing the values with the length. And if the chart is quickly shown on TV, most people won't notice the misstep. So these two, the discrepancy between these two charts is clear to the eye, yet it's not a big difference. So again, we can encode by angle. So encoding by angle means rotation between vectors, as you can see in this diagram. Encoding by angle. Angle range from 0 to 360 degrees on a circle. There's the 90-degree right angle, the obtuse angle that is greater than 90 degrees, and the acute angle that is less than 90 degrees. A straight line is 180 degrees. So here we have an example of encoding by angle. We have a pie chart and a donut. So the visual cue is relative degrees in the circle. So we have here a pie chart. You can see this is a 45. This should be, no, this is a 90 degrees, 180, and then 45, 360. So the difference between the pie and the donut is that the arc length is the visual cue because the center is cut out. So you use the arc length, unlike here where you use the angle. That's the difference between the pie chart and the donut. Angles range from 0 to 360 degrees on a circle. There's the 90-degree right angle, the obtuse angle that is greater than 90 degrees, and the acute angle that is less than 90. A straight line is 180. I think that's a repeat. Sorry. For each angle in between 0 and 360 degrees, there's an implied opposite angle that completes the rotation, and together, these two angles are considered conjugates. This is why angles are commonly used to represent parts of a whole, using the fan favorite but often maligned pie chart shown above. The sum of the wedge makes a complete circle. So next we have encoding by direction. Encoding by direction means slope of a vector in space. So as you can see in the diagram here, direction is similar to angle, but instead of relying on two vectors joined at a point, direction relies on a single vector's orientation in a coordinate system. You can see which way is up, down, left and right, and everything in between. This helps determine slope as shown below, above that is. You can see increases, decreases, and fluctuations, the amount of perceived angle, the amount of perceived change depends a lot on the scale as shown in the figure below. For example, you can make a small change in percentage look like a lot by stretching out the scale. Likewise, you can make a big change look like a little by compressing the angle. There's a diagram below which I will show. As a rule of thumb, scale your visualization so that direction fluctuates mostly around 45 degrees, but this is hardly a concrete rule. The best thing to do is to start with this suggestion and then adjust accordingly based on context. If a small change is significant, then it might be appropriate to stretch the scale so that you can see the shift. In contrast, if a small change is not significant, don't stretch out the scale just to make a shift to look dramatic. So here is an example that I was talking about. If you look at this diagram here, you can see if you look at the scale here, so this is 5, 10, 15, 20. So you can imagine, for example, if the scale was 5, then maybe 30, then maybe 60, a big scale, you wouldn't see, the angle would be very small. So I think depending on what you're trying to tell in a like, for example, in a data story, you can either stretch the scale or make it smaller. So here we have same values but different slopes. So you can see that the scale here is quite different, and the slope, as you can see, is dramatic. So when the scale is bigger, the slope is dramatic. So here again, we can encode by shape. So encoding by shapes means having symbols as categories. So as you can see here, there's a square, a rectangle, and a circle shapes. Shapes and symbols are commonly used with maps to differentiate categories and objects. Location on a map can be directly translated to the real world, so it makes sense to use icons to represent things in the real world. You might represent forests with trees or residential areas with houses. In a chart context, shapes to show variation are used frequently than they used to be. When graphs were drawn with paper and a pencil and computers still worked with punch cards, symbols were an easy way to differentiate categories. For example, as shown below, triangles and squares could be used in a scatter plot. We had looked at what a scatter plot is, which is quicker to draw than to switch between colored pencils and pens, or fill a single shape with a solid or a cross-hatched pattern. So if you look at the example below, we have different shapes in a scatter plot. So you can also encode by shapes. For example, forests with trees, like we said. So that's encoding by shape. We also have, we can encode by area and volume. There's a difference between the two. Encoding by area is how much two-dimensional space. So two-dimensional 2D, that's encoding by area. And then encoding by volume is how much 3D space. So you can see the difference. So we have 2D by area, 3D by volume. Bigger objects represent greater values, like length, area, and volume can be used to represent data with size, but with 2 and 3 dimensions, respectively. For the former, circles and rectangles are commonly used, and with the latter, cubes and sometimes spheres. You can also size more detailed icons and illustrations. Be sure to mind how many dimensions you use. The most common mistake is to size a 2 or 3D object by only one dimension, such as height, but to maintain the proportion of all dimensions. This results in shapes that are too big and too small, which makes it impossible to fairly compare values. So for example, say you use squares, shapes with 2 dimensions, width and height to represent your data. The greater value, the greater the area of a square. So if one value is 50% greater than another, you want the area of the square to be 50% greater than the other. However, if you increase the size of the square by 50% instead of the area, which is what some software does by default, the larger square is too big. Instead of an increase in 50%, it's an increase of 125%. I will illustrate, don't worry. We'll see the diagram below. So you run into the same problem with a 3D object, but the mistake is more pronounced. Increase the width, height, and depth of a cube by 50%, for example, and the volume of the cube increases by 238%. So here, if you look at this example, this is 1 unit. So here, 4 units sized by an area. This is 4 times the area as unit square. So you can say the first one is 1, the second is 4, and then here 4 units incorrectly sized by side length. I hope you get the concept here. It's not adding up. This is 16 times the area as unit square, and this is 4 times. So you should be careful about sizing by area. Sizing by volume, this is 1 unit. These are 4 units sized by volume, 4 units incorrectly sized by edge length. So this is 32 times the volume as unit square. So the other one, you can encode by color, which we had briefly looked at and we'll look at it into more detail when we come to what we call the color wheel. So we can encode by color. We can encode by color saturation, that is the intensity of a color or a hue, best illustrated in this diagram here. This is what you mean by a hue. So that intensity of a color hue, that was the color saturation that we have. Then we have hue referred to as color. This is what you commonly call color. When someone says red, green, we call color hue. So we're almost done. Color as a visual cue can be split into two categories, hue and saturation, like we had seen. They can be used individually or in combination. Color hue is what you usually just refer to as color. That's red, green, blue, and so on. That is color hue. Differing colors used together usually indicates categorical data, where each color represents a group. Saturation is the amount of hue in a color. So if your selected color is red, high saturation would be very red. And as you decrease saturation, it looks more faded. Used together, you can have multiple hues that represent categories, but each category can have varying scales. Careful color selection can lend context to your data, and because there is no dependency on size or position, you can encode a lot of data at once. However, keep color blindness in mind, like we had seen, if you want to make sure that everyone can interpret your graphics. Approximately 8% of men and 0.5% of women are red-green deficient. So when you encode your data, only with those colors. This segment of your audience will have trouble decoding your visualization, if they can at all. The figure below shows how shades are perceived by those who are color deficient. Previously, we had seen the blindness in a technical way. Here, this is in a layman's way. So here we have no color deficiency. That is a normal eyesight. Then we have a red deficient, and then we have a green deficient. So these are color vision deficiencies. We also have to consider those people who are colorblind when we are making our visualization. So I think we'll proceed from perception of visual cues next time. We have a quiz, which I think Eric has allocated. I think we might take this time to just quickly do the quiz, then we'll review. So I hope you've all done the exams, and from what I'm seeing here, I think everyone has gotten the concept of choosing the chart type. I think it was quite easy, but at least we've all gotten the concept, which was the aim of this lecture. So I think we'll just briefly go through the exam. A minute as I try to pull it up. Then after we are done reviewing the exams, anyone who has a question or a suggestion, confront it. So if we can look at question number 1, which type of a chart is suitable for analyzing trends? This one almost everyone got it right, except for a few. So here the answer was a line chart. Remember we said that when you're looking to analyze trends, the most obvious kind of a chart is a line trend. So for analyzing trends, line is the correct answer. Question number 2, which type of a chart is suitable for showing compositions of something? The answer was a pie chart. Remember, we said that when you add portions of a pie chart, they all add up to 100%. So a pie chart, each slice shows a composition of something. So the answer there was a pie chart. Which type of a chart is best suited for showing a distribution of data? The answer was a scatter plot. Remember we said a scatter plot shows a distribution in terms of circles. And when you make those circles to be either bigger or smaller relative, it can be a combination of a scatter plot, and a bubble chart. So the answer for number 3 was a scatter plot. So number 4, which chart is best suited for understanding the relationship between value sets? So the answer was a bubble map. Remember we said, again, the size of the bubble represents the portion that the variable is taking. So question number 4, the answer was a bubble. And I think that's it for the quiz. It was pretty simple just for you to grasp the concept that we were taught today. So I'd like to ask if there's anyone with a question or a suggestion. So somebody is asking for their results. I think we'll send them briefly. So meanwhile, is there any question?
Hi. For
Hi.
the class, you're supposed to get it in your email. It surely tells you the what you've scored. It's supposed to be instant once you finish the exam.
Are there any more questions or concerns as regards to today's session? So if not, then we'll meet for the next session where we're going to cover data encoding. We'll continue with data encoding. Then for those who are not there for the previous class, we can send you the notes either via email or we share them on a shared folder, then we'll send you the invites. For the links, I think you have them on a group chat. So you can even go through those visualizations, then you have an idea of what you intend to achieve eventually after the course. Then maybe if you have any questions, you can ask me either privately or in class.
Before we end, the person who had the question about the results, I can share my screen and show you how to access it from the exam platform. So let me just do that real quick. So once, I'm assuming you can see my screen.
Yeah.
So once you've logged into the exam platform, it should bring you to this page where you have your results, most recent score, and your exams. So for the exams that you've done, if you go to your results tab and view more, it's going to bring a list of the exams that you've done. And then you can just pick any one of them, actions, view. And then it's going to show you how you performed on that exam, what you got right, what you got wrong, what the correct answer was supposed to be. So that's one way you can view the exam. And as Maria said, as soon as you are done with the exam, it emails you what result you got. But from the platform, you can actually go and review exactly what questions you got right and what questions you got wrong. So yeah, so I hope that answers you. Okay, so Dan, you've seen the question of getting the previous notes.
Yes.
Oh, okay, good. Yeah, so we'll get those and then distribute them.
Yeah, I'll actually share them with you, Eric.
Okay.
Yeah, and then you'll see the best way to distribute. Either they come to your platform or you can
Yeah, just send them all to me and I'll figure out how to get it to them.
Yes.
Okay.
Have you been able to access the 4IR platform? Okay.
Yeah, Mary, I think there are still some issues with accessing it because I know even for me, and I need to follow up with Bryant on that.
Okay, fine.
Yeah. Okay. Yeah, for all those asking, once Dan sends the notes, I'm just going to send it out to everybody. So don't worry about that. I'll make sure that everybody gets access to them.
And all those links are also contained in the notes. Links to
Okay.
everything that I've taught. Yeah.
Okay. Okay, for all those who have problems with 4IR, just let Mary know. And then we are going to do a follow-up and see how we can correct that for you as well. Okay, if there's no other issue, I guess we can call it a weekend. So I've sent just a brief of what to expect next week. We have 3 more classes of data science left, and then we're going to have 2 classes of data visualization on Monday and Tuesday. Then the schedule for the rest of the week, Wednesday, Thursday, and Friday, we are going to share that definitely by Monday or during the course of the day Monday. So at least you'll be aware of what to expect the rest of the week. But for Monday and Tuesday, we have data science, 3 classes and 2 classes of data visualization. Okay, so that's it from me, unless Mary, you have something else?
Nope, I have no other remarks, but I'd just like to thank you guys for the past week. You've been very cooperative and you gave us an easy time. Hope we'll have more interaction next week. And in case you have an issue, kindly let us know so that we can assist you and the training may be beneficial to you. Thank you so much. Have a nice weekend and see you next week.
Okay, bye.
Bye.
Bye.